Hello students, the topic is longest common subsequence. So in the exam you will be given two strings and you will be asked that find out the longest common subsequence of these two strings. So let us understand the topic first. Longest means that you have to find out the longest string. Common means that you are given the two strings and you have to find out the one single common out of the both strings, one common string, right? Subsequence. What does the subsequence means? A sequence of the characters that are arranged in the increasing order, right? So longest common subsequence means that we have, like, we are given two strings and we have to calculate the longest common subsequence of those two strings. So as you can see here in the question, we are given two strings, one is x and one is y. X has AB double A B A, y is BA double B AB. So how can we find out the longest common subsequence? First, we will draw a table for it like this, as you can see on your screens. Right, so this is how we will draw a table for it. We will take the x values here on the y-axis and the y string on the x-axis like this. Right, and we have taken the x like this in a column and y-axis in a row. So here, what is this lambda meaning? This lambda is a null string. Why are we taking this null string? Because we are taking our first row and column as 0. Here you can see that we have taken our first row and column as 0, right? So we have to take any supposed value as our initial value. That is why we are taking the first row and column as 0. This is the logic behind it. So we are taking the x-axis here and the y-axis here. You can also name it as I or j, but x or y makes it a bit more understandable. So how are we going to fill up the first box, this one? You have to compare it this A character with B. If it is similar, you have to compare this character with this character. If it is similar, you have to add 1 into the diagonal value. Which one is the diagonal value? This one. This one will be the diagonal value for this box, right? So if it is dissimilar, you have to go one row back or one column back and you have to take the maximum of that, right? So this is how we can solve the complete table like this. Now I will explain that how we have find out all the values. So first I compare A with B, both are different, so I will go one row back, one column back, so both are zeros, so it does not matter either I take this value or this value, so I will take 0 and must mention which value you are taking. So I have taken this value, so I will point the arrow towards the left. Right, again I will compare A with A. Now see, both the characters are similar, so if we find a match, we have to add 1 into the diagonal value. So the diagonal value for this is 0, so we have added 1 into it, so we will write 0 plus 1 1 over here. And from where we are getting this value? From the diagonal, so we'll point it like this, upward, right, in the middle to that value, right, into the cross. Again we will compare A with B, so we will, so that does not match, so we will check, we will go one row back, one column back and take the maximum one. So the maximum one is 1, so we will write 1 here and point it towards the left. Again we will compare for the next column A with B, so they are not similar, there is no match, so we'll go one row back, one column back, take the maximum of that, that is 1 and the maximum one is to the left, so we will point an arrow to the left. Compare again for the next column, that is A with a match is found, so we will add 1 into the diagonal. The diagonal over here is 0, so 0 plus 1, 1. We will write 1 here and point it towards the diagonal. That we are getting this value from the diagonal just in order to indicate this, nothing else. Again compare with the next column, A with B. No, that they does not match. So go one row back, one column back and take the maximum. The maximum one is 1. So write 1 here and point it to the left. Come to the next row. Compare it with every column. B with B, a match is found. So this is the diagonal, add 1 into the diagonal and write 1 here. Compare it with the next column, B with A, they does not match. Go one row back, one column back, so both are 1, 1 and 1. Either take this one or this one, so I have taken this one, so I will point it towards the left. Compare it again with the next column, B with B, a match is found. So here we have to add a 1 into the diagonal. The diagonal here is 1, 1 plus 1, 2, write 2 here. Again compare B with B, a match is found. So here the diagonal is 1. Here we again have to add 1 into the diagonal and write 2 here, right? Compare with the next column, B with A, they does not match. Go one row back, one column back and take the maximum one. The maximum of them is 2. So we'll take 2 and point to the left, that we have taken this value. Compare with the last column, B with B, a match is found. So go one row back, so add 1 into the diagonal, right? 1 plus 1, that is 2. Come to the next row. Start comparing this character with all the columns. A with B, so they does not match. Go one row back, one column back and take the maximum one, that is 1. A with A, match is found. Add 1 into the diagonal. 1 plus 1 equal to 2. A with B, so they does not match. Go one row back and one column back, take the maximum one, both are 2. Either take this value or this value, that does not matter. So I have taken this value, I will write 2 and point the arrow towards the left. Compare A with B, they does not match. Again go one row back and one column back, so both are 2. Either take this one or this one, so I have taken this one, so I will write 2 over here and point the arrow towards the left. Compare A with B, so a match is found. Add 1 into the diagonal value, that is 2, 2 plus 1, 3 and point the arrow to the diagonal. Compare A with B, so that does not match. So go one row back, one column back, take the maximum of that. So 1 is 3 and 1 is 2. So out of both of them, 3 is maximum. So we'll write 3 here and point the arrow towards the left. Come to the next row and compare it with all the columns. Compare A with B, a match, they does not match. So go one row back, one column back, take the maximum one, that is 1. A with a match is found. Add 1 into the diagonal. 1 plus 1 is 2. Compare A with B, they does not match. Go one row back, one column back, take the maximum one. So both are 2. Either I take this one or this one, they does not matter. So I have taken this one, so I will write 2 and point the arrow towards the left. Compare A with B, so they does not match. Again go one row back, one column back, take the maximum one. So both are same, so I have taken this one. Compare A with A, so a match is found. Add 1 into the diagonal. The diagonal value is 2, 2 plus 1, 3 and point the arrow towards the diagonal. Compare A with B, so they does not match. So I will go one row back, one column back, take the maximum one of them. So both are same. I have taken this one and pointed the arrow to the left side. Compare now the next row. Compare B with all the columns. B with B. So a match is found. Add 1 into the diagonal. Diagonal here is 0. 0 plus 1, 1. Compare B with A. So go one row back, one column back and take the maximum one, 2. B with B, a match is found. So add 1 into the diagonal, 2 plus 1, 3. B with B, again a match is found. Add 1 into the diagonal, 2 plus 1 equal to 3. Compare B with A. So they does not match. Go one row back, one column back, take the maximum one. Both are same as 3. So I have taken this one. You can also take this value, but I have taken this. Compare B with B, again a match is found, so add 1 into the diagonal, 3 plus 1 equal to 4. Now come to the next row, that is our last row, and compare it with all the columns. A with B, they does not match. Go one row back, one column back, and take the maximum one, that is 1, write 1 here. Compare A with a match is found. So add 1 into the diagonal, 1 plus 1, 2, write 2 here. Compare A with B, they does not match. Go one row back, one column back, take the maximum one, that is 3, write 3 here. Compare A with B, they does not match. Go one row back, one column back, both are 3, take any one of them. I have taken this one. Compare A with A, so a match is found. Add 1 into the diagonal, 3 plus 1 equal to 4, write 4 here. Compare A with B, so they does not match. Go one row back, one column back, and take the maximum one. Both are 4, so we can take any one of them. I have taken this one, so I will write 4 over here. So this is how you can fill the table to find out the longest common subsequence. So we are not done up till here. We still have to find how many characters our longest common subsequence will be having, and what the actual longest common subsequence we will get. So moving forward, the last value in the row, that is 4, it can be in any other strings, it can may vary. So the last value will tell us how many characters our longest common subsequence will be having. So you have to encircle it, that our longest common subsequence will have 4 characters. How to find out that? Now we will find that longest common subsequence, right? So we will start from this last one, that is 4. So from where we are getting this 4 value? From this one row back. So here, from where we are getting this value? We are getting this value from the diagonal, right? So we will match it with the corresponding row and the corresponding column. Both are same, write A here, right? So coming to this 3, we are getting this value from, are getting this value 4 from the diagonal, so we will move to this diagonal 3. So this, we are getting this value also from the diagonal, so we will compare it with the corresponding row and column, they are same. We will again write B. Now from where we are getting this diagonal value, this from this diagonal, right? So that is 2. From where we are getting this value? We are getting this value from the left, this diagonal, that is 2. So we will compare it with the corresponding row and column, both are same. Again write A here, right? So where were we? We were here, right? So we are getting this value from the diagonal one, that is 1. From where we are getting this value? From the upward column, one column back, this is 1. So this is a diagonal, we are getting this value from the diagonal. So we will again compare this value of the diagonal with the corresponding row and column, that is B and B, both are same, so we'll write B here. So the substring we have find out, that is A, B, A, B. Which are the diagonals one? This one, this one, this one, and this one. But remember one thing, you have to fill up the diagonals from right right to left. See, first we have written this A, this one. Then we have written B, this B, right? Then we have written A, this A. Then we have written B, this B, right? This diagonal. So wheresoever you are getting the diagonal from this last value, you have to compare it with the corresponding row and column. If both of them match, you have to write it over here, right? So this is the longest common subsequence we will get from the both the strings given, that is x and y. And as we have already calculated the characters of our longest common subsequence from the table using the last value, that we said that we will have 4 characters in our longest common subsequence. And now we have calculated the longest common subsequence and there are 4 characters in it, right? So you got the approach how to find out the longest common subsequence. First, you will be in the question, you will be given, let me give you a recap, that in the question you will be given 2 strings and you will be asked to find out the longest common subsequence of that. You have to draw a table like this. You have to take the x values here on the as in the column and the y values here on the x-axis, right? And you have to take the first row and column as null value. Then you have to compare every row, the row with the column, and if they does not match, you have to go one row back and one column back and take the maximum value of it. But if both the characters match, then you have to add 1 plus 1 into the diagonal value and fill that box. So in the same way you can complete the entire table, and in the end you can also determine that how many characters our longest common subsequence will have after filling the table. The last value will tell us how many characters our longest common subsequence will be having. In this longest common subsequence, we find out that we will have 4 characters in it, and afterwards when we calculated this longest common subsequence, yes, there were 4 characters in it, that is BA, right? So this is the longest common subsequence.